Okay, I want to talk about something called Pascal's triangle and how you can use it to expand powers of sum of two things. So it's a very simple rule to create this thing. I'm going to start with a 1 on top, and for every entry in the, I'm going to build a triangle down like this. So every entry in the triangle, I'm just going to add the numbers above the entry. So here there's only 1 so far, so I'm just going to put 1s in the next row as well. Okay, and now like the third leg of the triangle is going to have 3 entries. For the one all the way on the right, like I add the entry above it, so there's a 1. For the one in the middle, like I add the 2 entries above it, so it's 1 plus 1 is 2. And for the third entry, like there's only 1 entry above, so I put 1. Okay, so now for the third, so I'll call this level 0, I'll call this level 1, this is level 2. So I'll call this level 3. For the third level, I'm going to do the same thing. So for this entry, I'll put the number above it, so that's 1. For this entry, I'll add the 2 numbers above this entry, so that's 1 plus 2 is 3. For this entry, I'll put 2 plus 1 is 3. And this entry, there's only a 1 above. Okay, so now for the fourth row, I'll do the same thing. So I do 1. Here I get 3 plus 1 is 4. I get 3 plus 3 is 6. I get 3 plus 1 is 4 and 1. And I can continue doing this. So this can go on for as long as you want. So 4 plus 1 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5 and 1. And maybe I'll do one more row. So 1, 6, 15, 20, 15, 6, 1. Okay, so you can create this triangle for as many rows as you want, right? So it's a simple rule to follow. You can continue doing this. So why am I doing this? You know, it's this nice symmetric triangle, but what's the point? The point is that you can use this triangle to expand powers. So for example, if I'm interested in expanding a plus b to the nth power, you can try to do it by hand, but it gets messy. So if I want to do a plus b to the 10th power, for example, you don't want to do that by hand, right? Maybe if it's only to the 2nd or 3rd power, I can just calculate all the terms explicitly. But if I want to calculate to the 10th power, this is going to be, I want a faster way to do this. And Pascal's triangle is a way to do this. So to calculate the nth power, what I'll do is I'll look at the nth row. So look at the nth row of the triangle. So if I look at this nth row of the triangle, it tells me the coefficients. So let's do an example. So for example, a plus b squared. To calculate a plus b squared, this is one that we already know how to do by FOIL, right? But let's use the triangle to do it. I look at the 2nd row of the triangle. So this is the 2nd row. And these tell me the coefficients of the expansion. So this is going to be a squared. That's 1 times a squared plus 2 times ab plus b squared. So you see the coefficients are 1, 2, 1. If we do the same thing with a cubed, a plus b cubed, how do I expand this out? I'm going to go to the 3rd row of the triangle here. And this is going to tell me that this is a cubed plus 3 times a squared times b plus 3 times a times b squared plus b cubed. So we could have FOILed that out and seen this, but if you notice, the coefficients are 1, 3, 3, 1. Okay, and you notice what I'm doing like with the powers. I'm starting with the first one cubed. That's going to be the largest power. Every term is going to have sort of three powers of either a and b, right? So this has 3 a's. This one has 2 a's and a b. This one has an a and 2 b's, and this one has 3 b's. And so I'm starting with the largest power, a cubed, and I'm sort of reducing the degree of a by 1 every term and increasing the degree of b every term until I get all the way up to b cubed, right? In general, if I wanted to compute a plus b to the n, one of the terms, I'm multiplying this thing n times together, right? One of the terms would be a to the n. That's if I choose a in every single one. But there are going to be other terms like a to the n minus 1 times b, a to the n minus 2 times b squared, all the way up to b to the n. That's if I choose b in every term in the expansion. And so this gives me an algorithm to compute this. Maybe I'll do one more. Let's say a plus b to the fourth. How do I do this? I go to the fourth row, and these tell me the coefficients, and I just expand out in this systematic way. So this becomes a to the fourth plus, what is the coefficient here? 4. So 4 times a cubed b plus, what's the coefficient? 6. 6 times a squared b squared plus 4 times a times b cubed plus 1 times b to the fourth. And so this tells me how to do this for any n. I can do a plus b to the 15th using this method if I want, and it's much faster than computing this by hand. So why am I doing this? This is going to help us take the derivative of x to the n. So if I wanted to take the derivative of x to the n, let's write this down. What is the definition? It's the limit. So I'm thinking of n as a positive integer right now. So think of n as like 10. So I'm going to take the limit as h goes to 0, x plus h to the n minus x to the n over h. And now this term can be expanded using Pascal's triangle. So you can try to take this derivative and see what you get, and this is gonna be the first step towards proving the power rule.